Hello and welcome to another video. Today we have an MSI board on our bench, a B450 Pro from a viewer. He wrote the following. Let's see. First of all, thank you very much for agreeing to take a look at this motherboard. This is an MSI B450-A Pro. The board powers on without a CPU, the fan spins and the CPU debug lights up as expected. However, as soon as I installed the CPU, known working Ryzen 5 1600, the board shows absolutely no reaction when pressing the power button. No fan spin, no LEDs, nothing. Following the kind of checks you usually do in your videos, I measured the main rails and resistance. The 12 volts, 5 volts, 5 ESP and 3 volts seem to be normal. I also have 3 volts on the power button. At this point I don't know how to go further. I really hope you will be able to find out what's going on. Thanks again for your help. Your videos are so helpful. Best regards. So, we have a board that does not react to the power button as soon as you have a CPU in there. And MSI on AM4 is one of the only boards that react to the power button when you don't have a CPU in there. So that is unusual, but that is normal for MSI boards. So usually we would expect there to be some sort of broken off components or a short. It's very interesting that when you power on the board with a CPU that does not want to react to the power button at all. It seems like some of the passive rails then are missing, like the 0.9 volts or the 1.8 volts. And that would be my suspicion here on this board. And today we are going to be using this thing here, a thermal imaging multimeter from FNIRSI. I'm very interested that I had many people ask me to, for example, in my power meters, to also include a multimeter. People love these all-in-one things. And yeah, this is a multimeter and a thermal imager in one. So we will have a look at that and try that out today. So let's have a quick look. This thing looks like it is wirelessly, so that there's a battery in there. And as always, nice packaging from FNIRSI. So let's have a quick look. We get probes in here. Let's see. They feel okay, so nothing special. I would probably prefer to put my own probes onto here, like to get sharp ones. These are okay, I would say. These are usable. The cable doesn't feel too nice. It's just okay. Then we get a USB-A to USB-C, probably for charging. A manual. And the actual unit itself. Not too much in the box. Unit feels very nice. Has quite some weight to it. So, let's see for connecting the multimeter, probably up top. Yep, COM port labeled. So, let's see. What does this thing do? So, this is the normal COM port that we have at the top. And then we can see here, it measures volts. Is that capacitance? It looks like capacitance, ohms, diode readings, and continuity. Okay. And so, this is an auto ranging. This doesn't need to be manually set. Oh, this has a very nice mount. Like, this is the mount that you have on tripods and everything. So that is nice to know. There we can see the thermal camera. Okay. So this takes 5 volts at 1 amps. It has a 1500 milliamp hour battery. It's rated for -20 to 400 degrees. And the thermal imager is a 120 by 90. So not the greatest resolution for that. But okay. So let's power on the device together for the first time. Starts up. Do we have, where's the USB port on this? Oh, we have connectivity here. Okay, so this supports a SD card probably for the video. And then there's also a USB-C port. Question is, can we also do like capturing via that? Okay, how do we, oh, is this a touchscreen? Oh, the thermal imager instantly starts. Okay, how do we, okay, that is image saved. How do we switch from to multimeter mode? Is the question. Okay, let's go back. Here, that is the multimeter mode. I'm firstly interested in that. Let's see. Yeah, this is just a touch display. Okay. It even does completely auto, but let's set it to resistance. Let's see if I may do some. No, there's no settings for this. Okay, let me see if I can capture this better. If this has PC software support. So I had a quick look. I don't think that this has support to like transmit its data via USB to a PC. I would love to see that, have like some sort of software, because they definitely can do that, because their power supplies have that functionality. So I would love to see that on this as well. But let's start using this thing with its multimeter to check for our usual resistances, even though he said that the viewer, that he already tested it. But let's do that together. So now I need to look out for capturing this as well. So we're not going to go as close as usual. So 3.3 volts. We see kiloohms and rising. Okay, it is not the fastest. I didn't expect it also to do so. But the auto ranging is good. So kiloohms also. Then 12 volts. We also could see kiloohms and 5 volts. Also kiloohms and rising. That's good. So let's go over to the 12 volt auxiliary for the EPS connector. And that has also kiloohms and rising. Let's check from the 12 volts to the CPU. And also kiloohms. That is good. Oh, it saves min and max values as well. Interesting. So the min values don't really interest us here. Because, yeah, the min values are capacitors charging at the beginning most of the time. So let's check some coils that we see around here. So all I'm doing is finding coils like these ones and just going to ground from them. And let's check. Yeah, kiloohms of resistance. Then another coil here. Kiloohms. Then another coil here. Also kiloohms of resistance. Then there's more coils over here. Let's get the multimeter better in view again. Then let's see right here. Oh, I think we found our culprit. 40 ohms on this coil. That is not good. Yeah, that is kind of what I expected for something that doesn't want to react to a power button press with the CPU. Interesting. So let's check this coil. 13 ohms also. Oh, you cannot. That's basically not visible. So the coil for the PCH right here has also very low resistance. Like, have a look at that. 13 ohms. That is quite low. And the input of it has higher ohms. Okay. So the coil for the PCH is kind of low, especially for B450. And this one is just shorted. Okay. So as far as I know, this is the 2.5 volt supply rail. And this is the 105 volts for the PCH. Let's see what this reads in the diode mode. Yeah, this just reads 0. And this one, 0.018. Also not great. Okay, this doesn't look too good for this mainboard so far. Oh, I don't even know how to proceed. Do we just go over to injecting voltage into here and seeing what gets hot? Probably, because this is just a dead short. So let me set up my power supply with 1 volt here. And let's then use the thermal imaging. So, now we have the thermal imaging. I haven't used this yet, so let's see how this reacts. I need to probably set my current limit not too low or too high. Let's set it a little bit lower. And let's see now. I'm going to inject voltage. Let me zoom out a little bit, because I don't really know how to capture this properly. So let's see. Injecting voltage, and there's something getting hot. Okay, that is way better visible than I expected it to be. Let's zoom down on that. I thought this would be not so great with the resolution, but getting heat spots like that is better than I thought. So let's inject. Right there. Something heating up. Is that? Where is that? Let me see. Oh, something right there. Is that a... Okay, I'm kind of confused of where I'm looking at, because the camera is at the top left And figuring out where I'm actually looking at is not as easy as I thought. So let's see. The biggest problem is the focus range. Like for electronics repair, you want a focus range that is appropriate. But yes, something here is heating up massively. Oh yeah, it's also... Oh, you can smell it. Okay, I currently have one hand too little to poke at the area where I want to be. Let's see if I go closer, if I can make out where this is. Because the contrast here is not so great. So the problem is, the heat spot is so high that I cannot really see what is around it anymore. And the frame rate also. Let me see, can we adjust the color range of this? Oh, we can set a distance here. Okay, let's see. I set the distance now to the very lowest setting. Let's see if that helps. So it says 50 centimeters. So this has a digital zoom. Okay, I think it's this chip, right? No, it's not this chip, is it? Is it that chip? Let's see that again. It would be easier. Oh, it's next to the M.2, something there. Okay, it would be easier if I would just solder a wire onto here. So you can see, it's hard to see. There's the M.2, and left to it is the heat spot. So it looks like it's a capacitor. It might be the chip there, but it's heating up quick. Like the values go up really fast. Yeah, 70 degrees. Okay, so at this range, it's definitely usable. It's definitely that chip next to that coil that is heating up. So you should set the distance to the minimum for focusing, and then use this if you want to use this for electronics repair. For other kind of repairs, you probably would do different settings, but for electronics repair, that is the way to go. So let's shut this down, and let's go on the microscope then. So this short that we saw is either that chip or one of these capacitors next to it. That I wasn't able to see in the camera very well because, yeah, it cannot focus down on the individual component. To see the general area of heat, it is definitely good enough to do that, but not to go to the actual individual ones. So let's pour some alcohol here. And let's inject voltage again, and let's see together if we can see... Oh yeah, that capacitor. Yep, like I thought, that left capacitor. Look at that, how it's evaporating. Oh yeah. So, let's get rid of that capacitor then. So we definitely have a short circuit on that. And it was decent to find it with the camera. But I got to say, it's lacking the feature of contrast. Like, I could see the area where it was shorted, but I couldn't really make out precisely what was shorted. I'm not too sure if that is a problem of like resolution or of distance to where it actually focuses properly. So I've soldered on the capacitor to the side. And let's now get the FNIRSI multimeter again. Let's check in continuity mode, in beep mode, so you don't have to see it, but we will be able to hear it. So we now in beep mode, and let's see. And I hope you can hear that. This capacitor is shorted. Yep. And with the position that it's in, it's not currently attached anymore. And that means that the short is gone. So I don't like the quickness of the response for the multimeter. It should be beeping every time I'm touching this here. But there's quite some delay to it. So yeah, definitely room for improvement of that. I'm not too sure if it's the probes or the multimeter that is the cause of this. But you can see, yeah. Okay, so we have gotten rid of this problem then. So question now is there still also a problem with other things? Like, for example, the PCH had low resistance. Let's check here again, where I was injecting voltage, if I still have low resistance. So against ground, I think that is ground. There's no short anymore. Let me go into a resistance mode and let me see. There's kilo ohms now. I know you can see that, but there's kilo ohms of resistance now. Okay, so no short circuit anymore here, but going lower, we still have low resistance here, I'm pretty sure. So checking from here to, like, I think that is ground. Now I can see it. Yeah, this is ground on the capacitor, and this still has 12 ohms. So I don't like that reading, to be fair. But 12 ohms is not a complete dead short. So let's try to power this board on and see what happens. I'm very interested in the passive power consumption of this thing. Like, if the power draw from the 105 volts that has low resistance will be visible here now. So, here goes nothing. Let's check passive power consumption. 112 milliamps. That is actually not too much. Okay. So 120 milliamps looks fine for now. Let's connect. I got a post code analyzer here. Let's get a power button and a speaker onto here. If we now even have a reaction to the power button. So let's see. Power is on, and let's press the power button. 2 amps. Postcodes are running. Okay. That is good to see. 2.1 amps. 2.8. We get post LEDs. I don't have a post screen on here. Let's see. Let's connect this up. Let's enable the post screen. Let's have a look. So 3.6 amps. Postcodes are running here, as you can see. This is connected to the TPM header. This looks promising so far because the BIOS was reset. And there are postcodes run. There's also post LEDs running right there. And I think we're getting a picture. Video not supported. Really? This happens so many. Oh, there it is. Actual BIOS screen. Interesting. So was it only that one single shorted capacitor? Because yeah, it's working. The capture is just that's probably just something with my capturing that is bad here. Either pin dirty or bad contact or something. There's an HDMI port. Let's see if I get better contact through the HDMI here. So I've now connected via HDMI. Let's cycle this board. So I cycled the board, and now what I want to do, I want to have a look at this board under the thermal camera, because I want to see if we can see like anything abnormal at the power supply for the PCH. So let's switch. And I got to say, on a further distance from the board, you can actually see way better. So when going further away, I can actually see the details of like the PCH and everything. So the biggest problem with this thing is its distance to where it focuses. If we can see right here, man, this is so hard to capture to get everything in a good frame. You can see at this distance, we can actually see components way better. And we can see that controller that is driving the coil only has 35 degrees. So there's nothing bad happening there. So this is definitely fine. I still get no signal. What is this, man? We should have a post screen right about now, but it does not want to display. Let me replug that. But yeah, at a closer focus point, so we cannot get any closer. If we get close as this, it gets blurry again, and it's better in focus if we're a little bit further away. So yeah, but it's definitely more usable than I thought. But you have to use the right draw distance. Like, you have to be the right amount of distance away from the board in order to check stuff. So this is definitely more budget orientated. It isn't the greatest, but it also doesn't cost so much. And if we look here, we can see, there's the signal, finally. Oh, yeah, that is just bad contact from my side. If I wiggle the cable, I get a signal and then not. But yeah, we can see something heating up there and right there as well. So yeah, we can see the regulators here working right now. And then also PWM controller working 52 degrees. All looking fine. So yeah, the camera is usable. It is not like the highest quality, highest resolution, but it doesn't claim to be that because it's more a budget-orientated product with a multimeter inside of it as well as an all-in-one unit to use. And I can see this more being used for like an electrician maybe, but even for motherboard repairs, especially if you're out in the field, I can see this. Like, don't get me wrong, the resolution compared to my usual thermal camera is not there. But this is better for focusing stuff that is further away and not so small components. But it definitely can be used. Like, I remember I started with the Seek Compact. And this is definitely better than the Seek Compact. And the Seek Compact cost me like 350 euros. And this, I think, this is 120 euros with the multimeter and the thermal camera in one. So not bad at all, I gotta say. It is definitely more budget orientated though. Okay, so enough of this for now. We won't be able to find out what the capacitor is like, what the value is, because it is shorted. We cannot measure it with this. So let's turn this off and let's get a proper capacitor onto there. So the area that we now need to work on again, let's go to the microscope. Or let's go, instead of going over to the microscope, let's go to a board view. Oh no, let's first see what we need. We need this here. MS7 B86 version 2.0. So let's open a board view for that. So here we are in the board view. And we had the short capacitor on the 1.8 volt regulator, I think. This I think is, yeah, this is a CPU 1.8 volt S5 regulator and has this here as well. This might be a load switch even, not too sure. But the short capacitor was on the S5 rail, so on the 1.8 volts S5. So the logic of the processor wasn't running because the 1.8 volts was shorted through this capacitor. And this is a 22 microfarad 6.3 volt capacitor 0603. So let me find one of those from a donor board, let's put this onto here. So right here on an MSI donor board, I found an exact replacement for what we need. So let's get some flux onto here. And let's just use the soldering iron to quickly remove this. No need for hot air. Just use a little bit bigger knife tip and then we can remove this. Just like that. Get tweezers to get this off of the soldering iron. Kind of like that. And now we're going to transfer it to our patient board. Like, this capacitor isn't mandatory, but yeah, for completeness, we're going to replace it. So now we can see same area again on our patient board. Let's take the shorted cap off of here. And let's get the donor cap into here. So let's connect both sides. Kinda like that. And the capacitor's in and beautiful in there. Let's also reflow this one. And yeah, no hot air needed. I can really recommend getting knife tips like that and just putting components in like that, because you saw how easy that was without heating up the whole area. That is just working great. So let's clean up. And that should be about it, probably. We're going to try to get this into Windows just to see that everything is working fine, like some USB as well, and the Ethernet as well. So test some functions of the PCH that they are working fine. So everything cleaned up. let's go to the overview again. And here's the board working. We're currently booting into Windows. I have 4 DIMMs of RAM in here, I have a 2600 in here. I put Ethernet on and some USB devices, and everything is working fine. So it's currently rebooting a couple of times because getting into Windows. And yeah, the Windows is via an M.2, so that slot is also working fine, just like the PCIe graphics card is working. So yeah, 13 ohms on the PCH was still kind of weird to me. Like, the controller isn't heating up at all. And yeah, usually I would say 13 ohms on a B450 is too low, but the PCH is functioning. The things that it should do is doing. So yeah, no problem with that. How did that capacitor short out? No idea. There's like, it's just a faulty capacitor. Like, nothing really to say about that, or if anything went wrong or anything. That looks like just bad luck. That is rare. Like, I haven't had a shorted cap on a motherboard for quite some time. But yeah, it does happen. And this time it was on a 1.8 volt rail for the CPU, and that's why nothing wanted to work. And yeah, so the repair comes to an end. My conclusion for this thing: thermal imaging camera is okay. It's not the best. It's lacking for like features to zoom down and focus, because also the resolution isn't the greatest, but it's fine. It definitely can work. Like, I've started with a thermal camera that had very similar performance to this and cost 3 times as much and didn't have a multimeter integrated. So yeah, for that price, that thermal camera as a beginner to even have a thermal camera, definitely fine. Multimeter is also okay as a portable one. Nothing too great, nothing special, but having all in one unit is quite okay. And I can see it very well with also mounting. I've seen that people like overhead mount their thermal camera in order to have it somewhere, or they put it onto a gimbal or something. And that is also nice that it was able to do that, and was also battery powered. So I think this is an okay unit, not the greatest. Even has a stand, didn't realize that. Getting into repairs, I think this is a good thing. This is nothing for seasoned veterans. Like, if you want, if you do this a lot, this isn't your thing. But for a beginner trying to start out, getting a multimeter and a thermal imager in one, this is decent, I think. This is definitely usable. I wouldn't say that this is top of the line, but for the price, definitely usable. So thank you very much, Fneezy, for sponsoring this video and giving me this review sample for free. And I hope you enjoyed the video, enjoyed the repair that we did. And if you have a board that doesn't want to react to the power button on an MSI board, you now know what kind of things to check: the secondary power supplies, in order to see for the CPU logic. If that isn't present, that the board doesn't even want to start at all. And even though it starts without a CPU. So yeah, thank you very much for watching. This was MainboardMedic. All of my tools are linked in the video description. If you want to get one of these current meters, email me in my video description. I have my email linked. And yeah, thank you very much for watching, and goodbye.